it's science! And a chick with glasses wearing a t-shirt that's like some comic book or something.
Hebbles.
Alright, okay, this is what I've got going on, right? I've got my Faraday cage. Jose Pate's the Faraday cage. And so basically what I've done is I've set this shit up now. So for one thing, it's tough as fuck, but second of all, like I've made it so you can take out the resistor and change the capacitor if you need to. The capacitor there stops DC going through, right? So it only lets the wiggles go through. So if you'll observe the oscilloscope here, this is the power supply, right? This is its power wiggles. Now, if I didn't have that capacitor in there, this line would be all the way up across here, and it'd be going wiggle, wiggle, wiggle at the top. But with that capacitor, it removes the DC component out of the wave and just has the wiggles around the center zero there. And one thing you'll notice is that it's actually asymmetrical, believe it or not, which I think is quite interesting. Anyway, so what we've got going on here is we've got a 10 mega ohm resistor, which turned out to be the key to all this. A little capacitor there to stop DC, and we go through there and we just put our probe on whatever the fuck we want. We've got the battery, DC to DC converter, and I've also got another one there. Now, I have realized that a 1K load is pretty easy to find, just 1K resistor, and I've got a couple that are all identical, which is good. And it's a good, it's kind of like a reasonable thing to put in there to get some decent fuck ups from the PSU, from the power supply, and it also doesn't get too hot. So yeah, it's a good mix. And I've got one set up here, and you can see what the resistor crossed against, the output ground, and output hot and output ground on this guy as well. Now, so the battery's going in, and I've just got myself a common ground. Everything's all ground. Ground is ground, and I've also put the battery's power into here, so I can just choose which one of these guys I want to power off the power rail. So at the moment I've got your PSU here set to be powered off, and I've got the probe going down there into his output, which is what I've got going on there. I've just got a couple of little jumper wires to make shit easier to see. But this here is the sensor probe going through there, and then all into the PC. Now, the way to sort of figure all this shit out is like to know what you're doing with in terms of volts. So just stick a multimeter across there. You go, oh yeah, okay. Between here and here, it's I don't know. It'll be 23 volts or 16 volts or something, whatever. And then when you go up to here, you'll look at the if I zoom all the way out on the oscilloscope, 0 dB there, that would be the voltage you read on your multimeter, right? Because it's 0 decibels below what you registered, right? And exactly the same on here. So we're looking at what do we got? Negative 40 dB or negative 42 decibels, right? You just use maths to calculate that into the microvolts. But we're working in such large dynamic ranges that it makes more sense to talk in decibels anyway. So anyway, so this there is a PSU. Now I can turn this up and hear this. And now if I adjust the trim pot on your power supply here, shit changes, right? Yep, now it's dropped completely. And to be honest, I have no idea. I don't understand the circuit fully enough, but I can guarantee you that if I changed the load on here, if I changed this load, then the position of what makes noise and what doesn't on this trim pot would change. It's like this resonance between the load and all the shit that's going on in here, and it's fucked. Now, the cool thing about this guy here, this DC to DC converter that I got ages ago, is that it's actually pretty fucking quiet. So if I plug him into our power rails that we set up from our battery, this guy converts, I think, what is it, 12 volts down to 9 or something like that. And at this point, oh shit, that was this is the 50 hertz, huh? So if I plug him into the output of my DC to DC converter on voltage out, you can see it's quiet as fuck, right? Absolutely fucking quiet. We still have the DC thing in there, but this I can minimize him a little bit with my Faraday cage, but it turns out shit's already like, you know, nicely sort of done here. Anyway, I still don't fully understand why I'm not picking up ground hum, but I'm just happy for that anyway. I think it's to do with this new resistor that I've got here, because it seems that the closer my probe gets to ground, the closer, the more DC, I mean, the more mains hum I pick up, the closer my thing is to ground, the more it picks up. And yeah, and this thing makes it very far away from ground. So anyway, let's stick that in there. Now, anyway, all right, this is my DC to DC converter that I've got from ages ago. Now, bear in mind my probe is is sniffing it, right? Sniffing my DC to DC converter. And if I plug in the one that we got, this 12-volt one that we for Pedal Boss, if I plug him in. Look at all this crazy shit that goes on. Okay, I can hear the noise more, right? But okay, the only thing that's going on here really is that they're sharing grounds. And if I start twiddling with this potentiometer knob, oh come on, do shit. Oh. Yeah, there it is. Now my probe isn't even on that DC to DC converter, right? It's on my one, but the problem is that they're sharing the same ground, and yeah, so it sort of effectively puts them into the same circuit. Now, if I get a capacitor, where is that? The 2200 microfarad capacitor here. If I shove it across the output of yours, everything should shut the fuck up because it buffers the power. So put that in there. Yep. It's basically it's attenuated it. Really, it's still there because I just need to increase the value of this guy. But that's why I have this 3300 microfarads, right? Plug it in. Ground. Positive. It's going to go snap. Yep. Now it's completely fucking silent. It's like it's not even there. But you can see that there's some actually. Look at that. See everything sort of going up and down and up and down and up and down, very very slowly. It's because it's like it's let everything through underneath like 0.3 hertz or something stupid. But there's all kinds of really interesting sort of like atmospheric crazy things that go on. But basically, you know, it's down at fucking, you know, down in the toilet, down at minus, you know, 102 decibels, whatever, which is effectively gone, you know. So anyway, yeah. Arduinos and science.